finding the area between two curves is just the difference of the areas of curves. So when I set this up, dividing this into a bunch of rectangles of delta x length, these two curves are going to share x values on the intervals a and b. So when I divide this up into rectangles, they're all going to be of length delta x, and ordinarily for one curve, the height of this, or the area of this rectangle, would be delta x times f of x. But since the area between these two curves is going to be whatever this area is of the top curve subtracted from the area of the bottom curve, then this becomes delta x times f of x minus g of x. And now they share the same set of x's, so when I set this up as a limit problem, it sets up as the area is equal to limit as n goes to infinity of the sum of f of x times x star times delta x minus the limit as n goes to infinity the sum of g of x x star times delta x, which can be translated into a set of integrals. Basically what I'm going to do is I'm going to integrate f of x from a to b, and then I'm going to subtract the integral of g of x from that same integral from the first area. And the resulting area will be the difference between the two curves. So this is what I'm going to be using to find the area between two curves. And the only other thing to watch out for is just to make sure that I choose the correct intervals for finding the area. They have to be on the same interval, and sometimes what I'll have to do is take more than one integral. For example, maybe something that's shaped like this. Let's say I only wanted to find, well, say I only wanted to find this area and this area. This is A, B, and this is C and D. Then I would have to integrate on A to B, those differences, and then I would have to add it to the integral from C to D, another difference. Well, it would be the other way. That's the only other thing to watch out for, is just to make sure to select the correct interval in order to find the area. It's just a difference of curves.